I believe your book calls this as new statistics, combining effect size, confidence intervals, but it's just a fancy word in my opinion. I do it pretty much. I've been doing it since a long time ago. But what is effect size? Well, we wanted to know whether an effect is significant or not. Agree with that? Yes. If we concluded that the effect is significant using a hypothesis test, then naturally there is statistical significance. Agreed. Okay. Now that we have established statistical significance, the next step is to determine whether it is practically significant or not. Correct. That's where this comes into play. Good. The effect size is a measure of practical significance. One of the commonly used effect sizes Cohen's d. Commonly used in social science. Now, in pure stats, we have other measures that we look at, but Cohen's d is something people go for in social sciences, given by a simple formula, something minus Planck's mean divided by standard deviation. For now, write the formula. I will do a simple example next time. One might wonder, well, sure, I have a formula for effect size. What does it mean? What does it mean to have an effect size of 0.8? Why does it matter? I call it the sample distribution. I don't want to confuse you technically. A different name. Reference distribution is also known as null distribution, or start with the letter C. O M E. What do you do when you have data and you have the reference? You take this and compare. So what is the name of the distribution? So the comparison. Reference, null, comparison, they all mean the same thing. Okay, let's see if you remember stuff from last time. I drew a picture similar to this one last time, and I said in this case, the conclusion will be, I'll give you two options and you can tell me which one we should pick. In this scenario, data is in red, reference in blue. Should you reject a null or not reject a null? By looking at this picture. Luana, you're shaking your head. What does that mean? Okay, no, rejected. No, definitely. what was
Oh, yeah.
same? No, reject, no, the others, do we agree? Now, who wants to give me a reason as to why you don't reject no? All right,
Due to the high amount of overlap, the probability that some distribution falls within the norm distribution is very high.
yes. In simple terms, you actually address that at the very beginning. Overlap, too much overlap, correct? I mentioned, I drew another case. This red curve has to be far from the blue. That is the entire point as to why we did critical balance. Well, far away to the right, but how far? That was the question we needed to answer. Obviously, in this case, significant overlap, you are not going to reject no, correct with me? Okay, so that is the conclusion by looking at the picture. Now, where is the effect size bit? A tiny difference, as you see, is simply the effect size. Is that relatively large, small? Just by looking at it, it is small, right? Without getting into any details, that amount is a small numerical quantity. So, by looking at the graph, I'm saying, well, small effect. We shouldn't be rejecting the null because the effect size is very, very small. But it's a fact. Here is the cautionary tale. We observe use logic, basic common sense, looked at that picture, said, well, the effect is very small, and oh, there is a lot of overlap. We shouldn't be rejecting the norm. But I raised this statement that says it is possible that a hypothesis test would reject norm if n is large enough. So it is possible for a statistical test to conclude that we are rejecting the norm in this case if you make the sample size large enough. Good. That is yet another way p-value to be cut, things that you shouldn't do. Just because you reject the null in a hypothesis test, it doesn't imply that whatever effects that you have, good, you've got to look at both. That's why I said, well, first step is to look at statistical significance. Next step is to look at practical significance. So in this case, hypothetical scenario. I'm saying statistically significant, not practically significant. What is my final conclusion? Do I have a significant effect? Yes or no? No. Summarize that as a simple table. First step is always assessing statistical significance. So, I'm going to ask whether it's significant here, significant there. Final conclusion. Conclusion is whether I have a significant effect or not. Step one, do the test using the data, then look at effect size, then conclude. Ready? You are going to give me the answer. Can I erase this? We'll do an example on this next time. I bet you won't be the textbook. Okay. Let's say test concludes that things are statistically significant. Effect size significant. What is the final conclusion? Do we have a significant effect? Yes or no? Yes. Test says, well, it is significant. Effect size, not big of an effect. Is there a significant effect? No. Test says there is no significant effect. Should I even go there? Good. So your starting point is to look at the data, establish statistical significance, then you go to next step. Look at the data and it's not supporting your hypothesis, don't even bother. Just give up. In other words, your hypothesis is not supported by data. Do we follow? Okay. Just like we have usual levels for significance, currency has standard levels. So if you are seeing a currency of about 0.2, then whatever effect that you're seeing is small. It's like buying a fountain pen. If it is about 0.5, medium. 0.8, large. Good. Now, these are where you start. One might naturally ask, what if I had 0.3? Would you say small or medium? It is safer to say small, right? What if it's 0.72? Should you say small or medium? Safer to say medium. So this is the starting point. Let's say you have two large. Good. So between small, medium, either the article would specify the effect size is 0.4. So from small to medium size, leave it at that. Instead of saying, oh, I rounded it up and quantitative, just leave it at that, it's better.
What's the same values for like correlation, C? No.
Good question. Let me answer that now with that. Declan North, are these the same values? No. The value of alpha is always the same. B level, same. No matter what test you take, people will not go for values such as 0.2, 0.3. I'll explain why. It's always 0.1, 0.25, 0.21. But these values apply only for Cohen's thing. Correlation has other measures. Test for independence has Cramer's coefficient. So each test, each scenario has a different measure. We will talk about those as we move along. I just wanted to introduce you to the effect size, so I picked this in this case. That's what the book does too. Harrison.
So do you never, is that rule with these, like never ever? Or
In this case, or in general?
in this case?
In this case, let's say you get 0.59. I'll just leave it at 0.59. And when I write it in the article, I'd say the effect size is 0.59.
What if I get 0.34?
I'll leave it as 0.3. Right? You don't say, oh, I'll just round it up, make it closer to 0.5. Leave it as 0.3. Good. In terms of probability, when we do stuff, I will reiterate this. You cannot round probability too much. You will get the wrong answer. 4 decimal places or more is the golden rule of thumb. Probability. Good. When we do a problem, I will explain last in detail. Are we clear with this? Okay. For the next class, we have hypothesis tests.